All right, so 3.2 is linear functions. So Nate, what word do you see in linear? Line. Very good. So everybody, let's box in this word line. So a linear function is basically all about lines, okay? So that's what a linear function is. It's a line, okay? So linear function in two variables is a relationship that creates a line. So we have two variables, and there's going to be a relationship between them, and that relationship will be a line. Okay? Now, there's more than one type of, say, function or relationship. Okay? There are quadratics, which are like a U shape. Okay? Quadratics are functions too, but we're not going to be talking about them. We're just going to be talking about linear functions. So for this section, it's pretty much going to be anything that has a curve to it is going to be non-linear, okay? And that's how we're going to refer to it. So a solution of a linear equation in two variables is a point that makes the equation true. So what do I mean by that? Okay? I'm going to take an easy one. Example, y equals x plus 2. And we're going to take the point 3, 5. And I'm asking, is 3, 5 a solution? So what I do is I would label my point x and y, and then I would plug it in. And I'm just asking, is 5 equal to 3 plus 2? Is that true or false, Joey? Is 5 equal to 3 plus 2? So then I like to put a check mark and say 3, 5 is the solution. Easy enough? Do you have a pencil? All right. A graph of a linear equation I do not. I have a Sharpie, and that's not going to help you out. So a graph of a linear equation is this. It's a line. So the graph of a linear equation is a line. A nonlinear function is a curve. Okay? So linear, line. Nonlinear, curve. Okay? Now, there are some more rules to it. Okay? So linear has to be one line. It can't be many different lines. Okay? So I can't have like jagged lines or different parts of it. Okay? It has to be one continuous line. But if I write all that down, then it's just going to overwhelm you, Nate, and I don't want to overwhelm you. Okay? Now, how can I tell, okay, in different formats if something's a line? Well, through a graph, Joey, I can look at it and I can determine if it's a line. Okay? I think you can do that, right? You could look at a picture and be like, that's a line, linear. Okay? But not everything is a line, right, Annie? Sometimes they give you like a table, like this. Now, if I give you a table, you're looking for patterns, meaning, are you going up by the same amount? Okay? And if you are, then you're good to go. Okay? So, let's look at these examples. Joey, linear or nonlinear? For A, is that a line? So it's nonlinear. Now, why is it nonlinear? Because it is a, what word did I use? Started with a C, ends in er. Starts with a C, ends in er. Put the two things together. Starts with a C, ends in er. Curve. Do you see the curve here? Yeah. Because it's curved, it's nonlinear. So I'd write because it is curved. Now, Annie, I was talking to you about a table, right? So if it's a table, it's got to go up by the same amount. Annie, how am I going from 3 to 6? Add by 3. 6 to 9, plus 3. 9 to 12, plus 3. Do you see how the x's are going up by the same amount? Which is good. Now, the y's have to do or go by the same amount, right? It doesn't have to be the same as the x's. It just has to be the same across the x's and the same across the y's. Do you see how all of these are the same? All right, negative 6 over 3, negative 6 over 3, negative 6 over 3. Do you see how they're all the same? This would be linear. All right, because it is going by the same amount. Now, no, that is not a formal math definition. I would use other words. But Annie, does that make sense to you that it's going by the same amount? Then we're good to go. Katie, does that make sense to you? We're going by the same amount for the x's, 3, 3, 3. The y's are negative 6, negative 6, negative 6. Okay. Katie, is number 1 here a line? Is that linear? Yeah. It's linear because it's a line. Definition of linear. Hey, what are we going by here? 1 to 3. So that looks good, right? 2 to 9. 9 to 20. 20 to... Are we going by the same amount? No. Notice the x's went by the same amount, plus 2, plus 2, plus 2. But the y's went plus 7, plus 11, plus 15. So this would be nonlinear. Because we are counting by different numbers. Nate, does that definition make sense to you? Do you see how we're counting by different numbers each time? 7, 11, 15. Now, yeah, there's a pattern there, right? 7 to 11, that's plus 4, plus 4. I could make an assumption that the next one would be plus 19, but it doesn't make a difference because it would still not be linear. So I want you guys to try 3 and 4. Tell me if it's linear or nonlinear. Three and 4.
Harmon, Harmon, Jules and Tyler are having internet issues. They can't get back on. And John may be having the same, but he's still on currently.
Okay. Thank you for the heads up.
Surely.
I think they sent me a message, but I didn't read it yet.
All good.
All right. Ellie. Ellie,
Yeah.
is number 3 a line?
Well, it's like half of a line, but it's also a curve.
All right, very good. Notice this here is a V. Remember when I was talking to you, I said it has to be one line. A V is more like 2 lines, agreed? It's like a line here and a line here. It's like one going down, one going up. So this is going to be nonlinear because it's like 2 lines. It comes to a sharp point. Mike,
Yup.
Mike, how do we go from 1 to 2?
You add 1 plus 1.
I add 1. How do I go from 2 to 3?
1 plus 1.
How do I go from 3 to 4?
1 plus 1.
So I'm adding 1 here. Now, Mike, how do I go from 16 to 8?
Minus 8.
How do I go from 8 to 4?
Minus 4.
How do I go from 4 to 2?
Minus 2.
Is that linear?
No.
This is nonlinear. Any questions? No questions. All right. So let's talk about what does a linear function look like in like equation form. So there's an easy way to do this. The easy way is take your calculator and plug it in. But I know not everybody has a calculator. So a linear function, okay, is one that has an x pretty much like by itself. The x isn't in the exponent, the x doesn't have an exponent, and the x doesn't have like a square root around it. And the x is not in the denominator. So basically it's a plain and simple x. There's also some exceptions for this. We could have one with no x's. All right, so what I'm really going to encourage you guys to do is this. I want you guys, if you have a calculator, to get it out, and I'm going to get mine. And we're going to see what they look like on the calculator. So let's look at the first one. Is everybody looking at the first one? So this is a TI-84, and it's a very useful tool. So what we can do is we come up here and we hit this button that says y equals, because notice this is y equals. And if there's anything in your calculator, we're going to hit the clear button. Now, I'm going to type in 3.8, and I'm going to hit this word called graph. Is that a line? Yes or no? Yes. So everybody for A, write linear. Let's look at B. B says this little square root thing. So I type that in, it's right there, and I hit X. Grace, is that a line or is that a curve?
curve.
So B is nonlinear. Let's look at C. Ava, is that a curve or a line? Okay, how about Cody? Is that a curve or a line?
It's a curve.
So we're going to write for C, nonlinear.
Okay.
And then for the last one, I'm going to type in 2 divided by x, and I'm going to hit graph. And then Chucky, is that a curve or is that a line? Chucky,
Yeah,
is that a curve on my screen or a line?
it's curved.
So it's nonlinear.
Yeah.
So long story short, anything with just a plain and simple x, like 3x, that's a line. Negative 5x plus 2. Notice the x is pretty simple. I'm not doing anything with it. I'm just multiplying it. Notice it's a line. See that, Joey? So I'm going to encourage you to use your calculator to determine if something is linear or nonlinear. All right.